You want to tell me what they think the answer is supposed to be? Yes, I heard it from Drea because she's sitting right next to me. But if you said no real roots, you can have a point. And then this is the part where I break Drea's heart, the way your parents broke your heart when you realized what you realized about Santa Claus. I know. It's my terrible joke of the day. I wish I had never come up with it. I need to let it go. That's actually not a true statement. No real roots is a lie. This problem actually has real roots. No real roots applies only to an even index. If there is a negative under the radical, the way there is on number 8, and we have an even index, aka a 2, a 4, a 6, an 8, a 10, then that's true. There are no real roots. However, we don't have an even index. 3 is an odd number. So I lied to you when I said there were no real roots. There are real roots to this problem. Now, why does it matter if we're even or odd? It all has to deal with exponents. So, for instance, we know 2, or negative 2 squared, is actually positive 4. You're on my nerves. We know negative 2 squared is actually positive 4. But negative 2 to the third isn't positive 8, it's negative 8. So there is a way to end up getting a negative cube root, because for my example here, negative 2 to the third is negative 8. So odd indexes are special. So there actually is an answer to this problem. Let's deal with the x to the minus 2 to the 12 first. So for my final answer, I should have x minus 2 to the what power? So the 4, because 12 divided by 3 is 4. And then for a point, what number should I have up front? It should be, I heard the number, but not quite there. If you say an I, I'm going to be mad at you again. It does have a real root, so no I is needed. Yes, it'd be negative 3. Because negative 3 to the third is negative 27. Or, again, if Caitlin had her calculator, and she's the one who taught us to press that math button the other day, if she typed in negative 27 on her calculator, cube root of negative 27, it's going to tell her negative 3. The exponents are odd. Good question. You can have another point for that. No one else is going to remember that, Drea, but that's good that you do. Okay, number 8, we're now done with. Let's back up to 6 and 9. So number 6, the x part's real easy. Yes, and you can have a point, Caitlin. I heard you loud and clear. It was not Caitlin. That was Jessica. Oh my gosh. Thank you, Caitlin, for being honest. Jessica, I maybe it's from a different angle or whatever. Oh my gosh. I have to get used to that. Okay. We've still got to deal with that cube root of 16, though. Sadly enough, we're not going to say, oh, okay, we're done. We're not going to do that now. On the test, it would have been a pretty number, like 27, because the cube root of 27 is 3, or 8, because the cube root of 8 is 2. But now we're dealing with reality, where there's not always pretty numbers. We need to somehow break that 16 down. So we have in the past, if we had a problem like the square root of 8, we would have said, okay, that's really 4 times 2. And we would have done 4 because we know the square root of 4 is 2. We would have picked a perfect square. We've done this for months. We've been picking perfect squares. But our index is no longer a 2. Our index is a 3. So we're not needing perfect squares. We're needing perfect cubes. Do what now, Derek? We are going to take out a 2. So 2 and 5 can have a point. We are going to take out a 2. It's going to end up being, so, 1 times 16, neither of those are perfect squares. Perfect cubes. What else multiplies to 16? 2 times 8, and what else? There's another. 4 times 4. Okay, that's great, but those are perfect squares. Neither of those are perfect cubes. 8 is a perfect cube. 8 is a perfect cube. So really we have cube root of 8 times 2. And then I know the cube root of 8 is 2. So really we have a 3x squared, a 2 coming out, and a cube root of 2 left under the radical. Because I know the cube root of 8, it's 2. The way I knew the square root of 4 is 2, I know the cube root of 8 is 2. Because 2 to the third is 8. Okay, well, last but not least, I know 3 times 2 is 6. So my final answer is 6x squared, cube root of 2. And you can write this like that, or if you want to put the x squared at the end, you can. So if you want to put number, so the 6, cube root of 2, and then the x squared at the end, you can. Either way is okay. So this one's good, or this one's good. But Caitlin wants to be careful. Either way, if she does this one, she wants to make sure that radical symbol does not extend over that x squared. You got to be careful about your symbols. Okay, if you have no idea how we went from cube root of 16 to our final answer, it's actually okay. Now, should you have understood because you already took a test on perfect cubes? Yes. But is life hard sometimes? Yes, it is. So we could actually figure this out another way. So when you were in, I want to say elementary school. I want to go back further than middle school. You used to make a prime factorization tree. Like 16 is 8 times 2. 8 is really 4 times 2. 4 is really 2 times 2. And then since our index is 3, we're going to need 3 of them together in order to have a match. So 1, 2, 3. That's why 2 came out. The 1, 2 left over. That's why that 1, 2 stayed inside. So you could always figure this out without actually knowing your perfect cubes, just if you broke it down to prime factors. Okay, last but not least on the math workshop, we're doing a 4th root of 32, x to the 5th, y to the 16th. The y is really easy, so I'm going to leave the x alone. The y becomes y to the what power? 4. Yes, and you can have a point for that, because 16 divided by 4 is 4. And now you and I need to deal with that 32, and we also need to deal with that x to the 5th. Let's deal with that x to the 5th first. Why are we mad at the x to the 5th? Yeah, because 5 is not divisible by 4, landing at some other point. So on the study guide, we changed it. We changed it to a 52, so it would be divisible by 4. And on the test, it would have been divisible by 4, but this is reality. Not every number is divisible by 4. The math teacher can't keep creating perfect numbers for you. We got to get down to reality. So in the past, or even with squares, we've done this before. I would say what number is divisible by 4 that's a little lower than 5, and I would make this x to the 4th x to the 1, because x to the 4 plus 1 is x to the 5. Now I know the 4th root of x to the 4 is just an x, so I had an x, a y to the 4th, I had a 4th root of 32, I'm going to leave that alone. I'm messing with that x to the 5th. I'm going to make that x to the 5th into x to the 4, x to the 1, because again, while 5 isn't divisible by 4, if I break 5 down, that number is divisible by 4. 4 divided by 4 is 1, so I know when x comes out, this x stays home. Now, if you did not like how I broke down those x's right then, you can always go back to our, I used to call it circle buddies. I guess it's really not a good term to use. Well, you know, buddies implies 2s, and our index is 4. But anyway, if you don't like how I figured this out, then you could always list them out. X to the 5th means 5 x's. Our index is 4, so you need 4 of them together in order for them to escape. Look, I did have a match of 4. That's why this x escaped. I have this 1x left over. That's why this 1x stayed home. So either way, you should be able to figure out the blue x's. And then sadly, we're still not done because we've got to deal with that 32. So I need a number. I need 2 numbers. 2 and 16 is what's going to work perfectly. Okay, so I don't know how he knew that. He can be a genius today. That's lovely. Okay, let's go ahead and combine those like terms. X1, that's going to be x squared, y to the fourth. Okay, and I know there's a fourth root. And I know for sure an x stays underneath. We're trying to deal with that 32. He knows that 2 times 16 is 32. That's a times symbol. It's ugly, but it's a times symbol. So he knows the fourth root of 16 is 2. So a 2 actually gets to come out, and a 2 is left at home. Now, sadly, Miss Compton has worked way too many of these problems in her life. So I know stuff like 2 to the 4 is 16. 2 to the 5 is 32. That's just things I've learned over time. But if you don't know those things, and you have no idea how Landon came up with 16 and 2, and he knew the fourth root of 16 was 2, that's fine. Again, I'm cool with this prime factorization thing. Corbin knows 32 is 16 times 2. He knows 16 is 8 times 2. He knows 8 is 4 times 2. He knows 4 is 2 times 2. His index is a 4, so he needs 4 of them together. That's why a 2 gets to come out, because he did have a match of 4. A 2 is left home, because this 1, 2 didn't have a friend. So even if he doesn't know his, because we never took we took a test on perfect squares and perfect cubes, and didn't take a test on the fourth powers. So he can still figure it out using prime factorization. Okay, I'd ask if there are any questions about this, but guess what? We're about to keep practicing it, because that's what today's notes are on. So take out your notes. Woo, I know. It's ironic how this is all happening. We're going to save the cylinder one for tomorrow. That's tomorrow's math workshop. Alright, Grace, will you get me a notes? Because for some reason, I remember I had to give a kid my notes last period, and I don't have one. I need one, but I don't have one. Thank you, ma'am. I do. I have a good one right here. You can go for it. Okay, we're going to only do 4 problems today. We're just going to do the top 4. In fact, we're going to make our life even easier. We're going to say we don't have to do the guided practice. I mean, you can if you want to do those 3 problems, but we're not going to assign them. Okay, so I know we just took a test with some of these on there. Again, these are the more complicated ones. We had pretty perfect ones on the test. Now we're in the real world, where they're not always pretty and perfect. We have 2 sections left, 6.5 and 6.6, and then there's another test. So I know you just took a test yesterday. I'm completely aware of that. I'm the grader, remember? But we have 2 sections and then another test, because we're only covering 2 more sections, and then chapter 6 is over. And then we start chapter 7. So why is this happening at the end of chapter 6? It's really all getting us ready for chapter 7, because we're about to get into the world of logarithms. And you've really got to be comfortable with your exponents and knowing stuff like 2 to the third is 8 in order to be successful with logarithms. So this is all trying to prep us for the next big thing. Okay, today there is a checkpoint. That's why you don't have to do the guided practice. But the good news is we're going to make that checkpoint a group checkpoint. The bad news is if Abby Grace is the only one in her group who works on the group checkpoint, Abby Grace is the only one in her group who will get points for the group checkpoint. So if everyone's not trying with a group checkpoint, they're not going to get their points for it. Okay, so we'll get to that in just a second. Let's handle these 4 problems. Number 1 is super easy. Yes, dear. Yes, please. X to the 4 square root of 2. Yep. Or he wrote it like this. Which is either way. I'm cool with either. And I'm going to give him 2 points for making my life so easy right then. 8 divided by 2 is 4, so the x to the 4th is easy. 32 is 16 times 2. Hey, I know the square root of 16 is 4. That's perfect. Okay, number 2 is not going to be as easy. Yes, dear. Is he correct? Okay, we'll give 5 2 points and 4 and 6 a point. Okay, 12 is really 4 times 3. I know the square root of 4 is 2, that's why it's a 2 and a 3. That part we're cool with. 6 divided by 2 is 3. We're probably cool with this as well. How did we end up with a D outside and a D underneath? Yes, and that's how I do it. And the way I hear it, like I know I heard Landon Jemiah explain it the way I do it, which again, probably because I'm your math teacher, so we all think alike now. So D2, D1, I know that one, so a D comes out, a D's left over. But again, if you are still lost, D to the third is 3 D's. Circle buddy it. 2 of them come, so I get a D out, a D's left at home. You can still circle buddy it and be successful. And I will never tell anyone that you're circle buddying it. It is fine. At least you're trying. Okay, but then we get to number 3, and it's harder because of that index of 3.
8 times 3.
Please tell me. Yeah.
So 8 to the second. B to the second. 3 square root of 3 seconds. C. 3 square root of B. 3b second to the C. Let's see if he's right. That's the ugliest 3 I've ever written. But he might be right.
Yeah.
4, 6 divided by 3 is 2. 2 left over. His B's are correct. His A's are correct. 8 times 3 is 24. That's correct. See? Yeah. How did you do that? Is there an app for this? That's cool. You can still have a point. That's cool.
I said no.
Oh. Oh, there's no app for this? I wish there was. Oh, okay. That's cool. That's still cool. Apparently so.
That's really cool.
Oh, that's cool. Yes, rating. Hold on. Okay. Hey, let me, Brady. Let me reality number 3, and then all of you.
That blew my mind. I'm
Okay.
not doing this like or 4.
As you should be. As you should be. Because in reality, is that ever, no. That's cool to know that. Okay. While this is great, you know that for the rest of us who are here on Earth, we need to like slowly go through it because that was deep real fast. Okay, so 6 divided by 3 is 2, so I'm cool with the A squared. And then beyond that, I gotta spend a little time on it. So I'm gonna leave the 24, the B to the 8, and the C alone for the moment. So everyone in the room should be cool with the A squared coming out because 6 divided by 3 is 2. Okay, 8's not divisible by 3. So instead, I think through, oh wait. Okay, instead, I think through what is divisible by 3, and since 8's not, I back down to a number that is, like 6. So I think of it as B6, B2, because B6 and B2 do give me B8. So that's a 6 and a 2. I know they're ugly. I wrote them there too. I know 6 divided by 3 is 2, so no wonder he has A squared, B squared. I know 2 divided by 3 is not going to work out, so I'm going to leave that 24 alone still. I'm still going to have a B squared left over and a C. Again, I did 6 times 2, or B6 and B2, because that adds up to B8. I know 6 divided by 3 is 2. Hence, I got the B squared on the outside. B squared and a cube root's not going to work out, so that's why there's a B squared stuck on the inside. But again, if Corbin's just hating this logic, he can still list it out. 2, 3, 4, 5, 6, 7, 8. He needs 3 of them to come out. He's got 1 set. 2 sets of 3, that's why it's a B2. He has 2 left over, that's why it's a B squared left over. So even if he's not liking this, he can definitely do the circle bunnies. I don't know which one of you it is, but you're trying to give me a seizure. And I got enough going on without having a seizure. The like, light thing on your phone. The flashlight thing. Because the flashlight thing. Okay, I'm never going to figure out, like, that c to the 1 is never going to be divisible by 3. So I'm done once I break down that 24. I've just got to deal with the 24. So I'm still set with my a squared and my b squared. Cube root, b squared, c. I've just got to deal with that 24. I need two numbers that multiply to 24. I need one of them to be a perfect cube. Yeah, it's 8 and 3. And you can have your point. 8 times 3 is 24. 8 is a perfect cube. I know the cube root of 8 is 2. So it's going to be 2a squared b squared, cube root of 3b squared c. But again, even if Corbin doesn't know his perfect cubes, he can still figure this out. He can prime factorization it. 24 is 12 and 2. 12 is 3. 2 and 2. His index is a 3, so he's got to have 3 of them to come out. Look, he had 3 2s, a 2 came out. He did not have 3 3s, a 3 was left under the raffle. Regardless, he should be able to logic his way out of this. Okay, last but not least, and I've written all over it, is this fourth root problem. So we're going to do it right here. Brady's been dying to, Landon. You can fix him if he's wrong. Go ahead, Landon. I mean, Brady.
2, 8 to the 6, b to the 3rd, 4th root of b.
Okay, let's see if he's right. Now, thankfully, this one is nice because 2 to the 4 is 16. So for sure, yeah, I'm sure he is right too. But for sure, the 16, 2 to the 4, 16. For sure, his 2 is right. We're happy with that. And then we're also happy with his A because 24 divided by 4 is definitely 6. So I know his A is right. Really, the only thing we could question Brady about are his B's. But again, if we're thinking through, okay, 13 is not divisible by 4, but 12 is. So really, this is b to the 12, b to the 1. 12 divided by 4 is 3. I have a 1 left over. Or I'm still saying if you want to do all the circle buddies of the world, I mean, I can list out b 13 times. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I can list it out 13 times. 4, 4, 4. That's why it's b to the 3rd. Has 3 sets of those. There's why this would be left over. He didn't have a friend. Like, I can figure this out multiple ways. I just have to take the time to figure it out. Okay, if you're cool with this, great. That's what our checkpoint is on. Again, we're going to call it a group checkpoint, so let me explain the rules one last time. Everybody in the group is going to get a copy, so everyone should work the checkpoint. It's just Miss Compton can't people today. I literally can't. So I only want to deal with one person from each group. So if Landon is the designated person, yes, Landon will show me his answers, but surely everyone else in Landon's group is also working on the checkpoint in order to get the points. If they are not, obvious one, yes, it'd be awesome. If they are not, then they'll get the 0 because they didn't help. Feels rather obvious, but I'll say it nonetheless. You do not have to do number 5 on this checkpoint. You only have to do the top 4 problems. You shouldn't have any homework, but it seems like every class period there's at least one group that can't get this checkpoint done. So that's what you would have to do for homework. Okay, that's all I got to say.